Hi guys, welcome to DSN Telugu YouTube channel. This is a part 2 of previous video, which is A2A protocol video. In previous video, I explained what are agents, what is A2A protocol, and how A2A protocol is helpful for agents communication, and I explained solutions of A2A protocol. In this video, let's try to explore the solutions of A2A protocol and how each solution is helpful for agents for communication. Let's try to understand what is the difference between A2A protocol and MCP at the end of the video. Let's get into the video. Let's try to understand the key concepts of this A2A protocol. Key concepts of A2A protocol. So as I mentioned previously, these are the solutions which the A2A protocol will provide, right? So basically communication protocol which the A2A provides is JSON with uh, RPC over HTTPS. So basically it uses internal HTTPS and JSON RPC to communicate with each of the agents. So try to understand this RPC. So it is a important concept. Let's try to see each one of these concepts below again. So what exactly they provide. Some of the core actors in the A2A protocol is user and client agent like my agent and remote agent. Remote agent can be agents, multiple agents like flight, weather, or hotel agents, right? This client agent will try to interact with all of these remote agents with the help of this user intervention. This is like human in the loop. Okay, these are some of the core actors involved in this A2A protocol. So now, what are the key concepts or what are the components involved inside this A2A protocol? So components involved inside this A2A protocol so that it can able to communicate with the A2 other agent. So here one of the important component is as I mentioned communication protocol. That seems to be a little generic, so I don't want to explain about the communication protocol. The other thing is discovery mechanism. So what exactly this discovery mechanism here is? So we have two agents, client and remote agent, right? Uh, so uh, so as of now, this is remote agent, and my client agent has A2A protocol, and remote has A2A. Now, how my client know what this remote agent will actually perform, like what it actually does? What is the responsibilities of this remote agent, right? Like whether is it a hotel agent or hotel booking agent or flight agent or weather agent, we don't know. So we need some metadata about this remote agent. So that is provided by agent card. This agent card is some JSON metadata document which is present on the server side of this remote agent. Like this remote agent has some APIs, right? This is registered over this API as an endpoint URL, and it has some information about this agent, like what is this agent, what it does, and what are the data types it accepts, and what are the data types it provides. I mean, data written types it provide, and what is the communication protocol, and what is the request and response format. Like, does it support asynchronous behavior or synchronous nature, like request and response? So, request and response formats. So basically, this is called agent card. It shows the information or metadata about an agent. So with this, it is able to understand, like client agent is able to understand what actually this remote agent will do. Now, Since we are able to understand the discovery mechanism, like what exactly this agent do, okay, and once they are able to connect with each other, now comes to the action part. So the next concept is task. So here, task is a simple unit of execution, which tracks whether particular action completed or not. Like, for example, we are trying to ask this remote agent to book for a service, or to book an hotel, right? So we need to have some thing to track the status, right? That is what the task here is. So whenever client requests to this remote agent will respond with a task submitted status. So task will have many different state, like submitted, uh, next, a progress, or cancelled, or execution in background. Maybe there can be many different states of the task. Based on that, our client agent will request the remote agent, or it will wait for some time until the response comes from remote agent. Next important or key concept is message. Message is a single unit of communication between the client and server or remote agent. So basically, any agent can send their own messages. Messages helps each agent to understand the communication part. Like, if my if I send a request to remote agent to book flights within range 19 to 20, this is one message, right? And the task is in progress, and remote agent can respond back with the same some message saying, you don't have uh, bookings in this range, or seats are not sufficient in this range. Then client agent can again respond, or request the remote agent to book from 21 to 22 age, or to choose within the same range different economy seats. So there can be a communication between client and remote agent. So this message will take care of that, and it has some information like what is the data they are trying to communicate with each other, and what is the who is the user, is it a client or remote user. So basically each message has an id. Next important concept is part. So part holds the data, basically, which resides inside a message, I think. And this has the type of data which client and server are exchanging. Like, they are trying to exchange text data, image data, or reports. So what basically this remote or our flight booking agent will do is, it can send some booking details in the form of PDF or in the form of Excel, or it can return booking details within this particular range in an Excel. So basically, this part will provide that information, like what's the data type and what's the data it is trying to provide. And next concept is artifact. So this is the final output which will be shared by remote agent to the client. These are the important concepts within this A2A protocol. Basically, the things which we had seen: discovery mechanism, task, message, part, and artifacts. This protocol will handle all these headaches. So that's how agent, which is an LLM, not need to worry about many things, like what actually client or remote is receiving. So basically, from this A2A protocol, this will receive some final output, which is an English language again, and this agent will automatically respond to that data, respond back to the data, and A2A protocol converts back again and send. This is like an HTTP protocol. We don't know how these network calls are happening, but we are able to send the data, right, within this APIs. Just like that, A2A protocol fulfill this need. So basically, A2A protocol will resolve these communication issues. Basically, these are some of the important concepts of A2A protocol. Now comes to response model. So if we see response model, we can have many response models like request and response, which means synchronous, which is nothing but pool. If the remote agent tries to execute a task, then client can request on the task, like what is the status of the task. Remote agent can respond back. Still it is an execution mode. So this is what synchronous request and synchronous communication is. So if remote agent supports asynchronous communication, like uh, so it can say to the client agent, like, don't disturb me until my task gets completed. Then there are two ways to do this. So first thing is, client will request to remote, and remote will send back to the client with some information like task is in progress, and keep this connection open. Then what it will do, when client and flight booking or remote agent wants to communicate, client sends a request and flight server responds back, please wait for some time, or keep this communication open, I will respond back. Then what it will do, it will keep this communication open, and client won't request any further request to the remote agent. So this is what server sent agents will do. I mean, this is the server sent agent protocol does on behalf of A2A protocol. So, so here the A2A protocol does that magic. It won't send any other request. It will wait for the flight agent to complete its task, and when flight agent responds back, because the still communication or the connection was open, then if it responds back with some task submitted status, then it will complete this request and response. This is one way. The other way is, if flight agent takes more time to complete, then it can have a webhook model, like client request and immediate response will come. Then when then this client not need to wait for this remote agent to complete. When remote agent will complete, it will call this webhook URL. Then the client can stop its client can assume that task got completed. So that is one model. So these are the response models which A2A protocol supports. So again, these are all we not need to take care. So just we need to wrap our LLM agent with this A2P protocol. Then the magic happens. These are some of the key concepts of A2A protocol. So this is the simple architecture of A2A protocol. So we have an agent, right? We have an agent which was built on Google ADK and Vertex API, Vertex AI, or Gemini models. These are some one of the local agent, and it can interact with with the APIs which is provided by this enterprise. Okay, through an MCP server. Okay, and now we have another agent which is built on OpenAI maybe, and or Microsoft frameworks, and it can interact with its enterprise APIs, which is not exposed to outside world, with an MCP server. Now, if these two agents wants to communicate with each other, we can have a common protocol, which is A2A protocol. So, and this forms a layer over these agents with all these necessary key concepts, which helps agents to interact with each other. Okay, so This is all about the A2A protocol and what magic it does to the agents, how it will be helpful to the agents. So now comes to the difference between this A2A protocol and MCP. What is the difference between A2A and MCP? So A2A comes into picture when two agents want to interact with each other, right? If the agents which are built on a different platforms or which are built by different enterprises want to interact with each other, then A2A comes into picture. So when this MCP comes into picture, MCP is nothing but model context protocol, which provide context to the model. Suppose we have some APIs which every organization exposes right internally to other microservices. So suppose we have some APIs, internal enterprise APIs, and someone from the outside wants to access this APIs. The enterprise don't want to uh, expose that API. So what they can do is generally they can build this agent, but how can this agent can interact with this API? So that's where MCP comes into picture. MCP forms a layer between this agent and APIs or enterprise APIs, so that LLM, when it comes to like book a flight for this particular date, this is a flight which user wants to book. If we gave this statement in English word, then what this LLM will do is it tries to contact the API like get or set, sorry, or book API, booking API, booking. It can contact with this booking API to book an flight. So that's what MCP does. Like MCP provides or exposes the APIs to the LLMs, so LLMs can interact to the APIs through this MCP, and users can interact with this LLM in a simple natural language that helps them to book some service with a simple natural language. So that's what the difference between MCP and A2A. A2A comes between the agents. MCP comes between the API and the LLM. So that's what this video about. Thanks. And I'm going to attach all these resources which I referred in the comment section. I referred Google A2A blogs. Basically, these Google A2A blogs are, I mean, A2A protocol is implemented by Google. So I directly referred these pages. I'm going to add this in the comment section. Thank you.